Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrell's intensive math class. Today we're going to start talking about fractions. In particular, we're going to learn how to compare fractions and round mixed numbers. But before we can do any of that, I want to introduce you to fractions properly, and I really want you to understand what fractions are. Because in order to complete fraction operations, you must first, of course, understand what fractions represent. And fractions, guys, the easiest way I could explain it to you, fractions are part of one whole. And they are written as follows. There is a numerator, which is on the top, and a denominator, which is on the bottom. A numerator and a denominator. And it describes a part of one whole unit. I like to teach fractions using circles, kind of like a pizza pie or an apple pie or whatever. If I have a pie that's cut into 8 equal slices, and I eat 3 of these slices here, okay? So I shade in these 3 slices. That fraction is 3 parts out of 8 parts, because the whole entire pie was made up of 8 parts. So the fraction of the shaded area there would be 3/8, because it's 3 parts out of 8 parts. Okay? And that is what a fraction is. A fraction describes a part of one whole. The numerator describes the actual amounts that you're dealing with, and the denominator describes the total amount of pieces that make up that one whole fraction. Give me 1 second, please. Okay, and we're back. All right, so let's look at this next one here. The fraction 2 over 5. The fraction 2 over 5 is read as 2/5 because it represents 2 pieces out of 5 pieces, which made one whole. This can be represented visually again. Let's stick to the pies. As such, if you see this circle here, it has 5 individual pieces. And these 5 pieces are all equal. And you have 2 of these pieces shaded in green. So that's why this fraction is 2 over 5, or 2/5. It's 2 pieces out of 5 whole pieces, which make one complete whole pie. So pretend you had a pie here, or a pizza, and you ate 3 slices. What are you left with? 2 slices out of 5 slices. You're left with 2/5. That is what fractions represent. It's part of a whole. When working with fractions, guys, try to visualize a pizza or a pie. And for example, let's name the fraction represented by each of the following, okay? We're going to use the numerator is the colored slice. So what would this first fraction be? Yes, sir. 1/4. Very good. Next. Yes, sir. Let's go down first. Please. 2/4. Very good, which will reduce to 1/2, and we'll talk about that later. Yes, sir. Yes, sir, please. 3 out of 4. Very good. Next, yes, sir. 1 out of 5. 1/5. Excellent. Yes, next, sir. 3 out of 5. 3/5. Excellent, sir. Yes, sir. 4. There we go. 4 over 5, or you could just say 4/5. Excellent, son. Excellent. You're very welcome. Does that make sense, boys? All right, let's move on. Now, what fraction is the What is the fraction of the shaded area? This time we're going to change it up. Some will be pies. Some will be different figures. But let's look at here, okay? Let's look at what we have here, rather. This fraction is the colored fraction, the colored pie or the colored rectangle. That is the numerator. The denominator is the total number of pieces that when added all together creates one whole. So what would this fraction be here for number 1? Yes, sir. I'm sorry? 1 out of 11 because I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 whole pieces, and I have 1 out of 11. Excellent. How about number 2? Yes, sir. Please wait till we call on you, son. Yes, sir. 4/5. Excellent. How about number 3? Raise your hands, guys. Yes, sir. 3 out of 11. Very good. Next, number 4. Yes, sir. 4/9. Very good. Excellent, son. Next, yes, sir. 3/9. Very good, which that can be reduced, but we'll get there. Next, yes, sir. 8 out of 9. Very good. Excellent, son. Next. Yes, sir. 5 out of 11. Very good. Excellent, sir. Next. Yes, sir. 10/11. 10 out of 11. Very good. 10/11. And last but not least, well, I'm sorry, number 9. Yes, sir. 1 out of 8. 1/8. Very good. And last but not least, yes, sir. 1/9 or 1 out of 9 or 1/9. Very excellent, gentlemen. Oh, hold on. Someone gave me 10/11. They counted wrong. Let's see. I should have double checked that. I'm sorry. That was my fault. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Sorry, that was my fault. I should have double checked. That's 9/10. There was 9/10, sir, not 10 out of 11. Thank you, though. That was my fault for not checking. I apologize. Thank you, guys. Okay. Now, I want to shade in now the figure with the indicated fraction. I want to shade it in. So let me go ahead and get a little highlighter here. Or actually, no, I'll just make it a little bit thicker here. Okay. Let's see what we got. 6/8. So that's going to be 1, 2, 3, 4, 5, 6. So all of this will be shaded. Because that's 6 pieces out of 8. Number 12, 9 out of 11. So I'm going to shade 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So all 9 of these will be shaded out of the total 11 pieces, which create one whole pie. Number 13, 6/7. Well, I've got here 1, 2, 3, 4, 5, 6 out of 7. So it's everything shaded in here. I'm shading 6 out of 7. Excellent. Number 14, 9 out of 12. So I'm going to be shading here 1, 2, oh, let me go back there. 3, 4, 5, 6, 7, 8, 9. 9 out of 12. So I shade 9 of these bad boys out of 12. 7 twelfths. Okay, I'm going to shade 7 out of these 12 because 7 is the numerator. That's what I'm shading. So I've got 1, 2, 3, 4, 5, 6, 7. 7 out of 12. So 5 will be left over. 16, 1/2. Literally, I'm shading one of these out of the 2. So 1/2. Right there, 1/2. 4 twelfths. I'm going to shade 1, 2, 3, 4 pieces out of the 12 pieces. All right, that got a little bit messy, didn't it? Hold on. Sorry about that. This should be right here. There we go. Because if I shade 4 out of 12, there should be 8 left. 1/10. That's just one slice out of the 10 slices available. 1/6. Now this is a good one. This is a cube. Think of a number dice. So it's just going to be one of these sides shaded out of the 6 sides. That's a great one. And last but not least, 5 out of 9. That means that 1, 2, 3, 4, 5 of these little rectangles are shaded in out of 9 total rectangles that form the whole. Does that make sense, gentlemen? Promise? So do you all understand what a fraction is and how to recognize one visually? All right, let's do it then. Now let's get to the lesson at hand today, my brothers. Okay, now, comparing fractions and rounding mixed numbers. Comparing fractions is very easy. In order to compare fractions, simply cross multiply, and I don't know why I put comparing, and compare the cross products. Okay? You compare fractions by cross multiplying and comparing the cross products. When comparing fractions, use inequality signs to compare them. Now, please remember that inequality signs, you have less than or equal to, greater than, or greater than or equal to. When you're reading from left to right, this guy right here is the greater. It's greater than. And when reading from left to right, this is less than. Remember back when you were in elementary, the alligator eats the large number. That's another way to think about inequalities. So let's just get right to it. Compare the fractions 2/3 and 3/5. Well, let's cross multiply like I had just talked to you about. Cross multiply. Okay? Cross multiply. When you cross multiply here, what's 2 times 5? Okay, so this cross product, which I'll put in red, is 10. When you cross multiply 3 times 3, what's that? 9. So now you compare the cross products. Who's larger, the 10 or the 9? So my answer will easily and clearly be 2/3 is greater than 3/5. Does that make sense, gentlemen? You promise? Awesome. Okay. Once you compare the cross products, you compare the fractions using the appropriate inequality sign, just like we did. Cool? All right, let's do it. Compare each fraction using inequality signs. Okay, what's 1 times 7? 7. What's 3 times 4? 12. Who's larger, 7 or 12? Okay, so 1/4 is less than 3/7. B, what's 9 times 3? 27. Excellent, gentlemen. What's 8 times 7? Excellent, gentlemen. Who's larger, 27 or 56? So 3/8 is less than 7/9. Okay, let's compare 2/5 and 4/5. What's 2 times 5? Cross products. What's 4 times 5? 120. 12. What am I talking about? 120. What am I talking about? 12. Wow, sorry. Had a little memory lapse there. That's 20. So who's the larger cross product, 10 or 20? So 2/5 is less than 4/5. How about D? 10/13 or 11/15? What's 15 times 10? 150. Very good. What's 11 times 13? 143. Excellent. So who's larger, 150 or 143? So 10/13 is greater than 143. And that means that 10/13 is greater than 11/15. Does that make sense? Gentlemen, you promise. Okay. Now, rounding mixed numbers. A mixed number, first of all, my brothers, is the sum of a whole number and a fraction, such as 3 and 2/5. What this literally means is it was a 3 added, so 3 wholes added for 2 out of 5 pieces. It was 3 wholes added to 2 out of 5 pieces, which gives me 3 and 2/5. Visually speaking, that would be 1 whole plus another whole plus a third whole plus 2 out of 5. So let's see, 1, 2, 1, 2, 3. Oh, hold on. That was bad. That was a terrible drawing. Yes, it was. Yes, it was. Okay. All right, that's horrible too. But 1, 2, 3, 4. Oh my gosh, why can't I get this? 1, 2, 3, 4, 5. There we go. And 2 out of 5, so it'd be this guy shaded and this guy shaded. So it'd be 3 wholes and 2/5. That's what a mixed number is. It's a whole number combined with a fraction. Now, in order to round mixed numbers, okay, there's 2 methods. Method 1. In order to round a mixed number, simply compare the fraction portion of the mixed number with 1/2. Compare it to 1/2. If the fraction of the given mixed number is greater than 1/2, increase the whole number part of the mixed number by 1 and drop the fraction. If the fraction part of the given mixed number is less than or equal to 1/2, actually, that's wrong. I'm sorry, that is wrong. If it's greater than or equal to, you increase. If it's less than 1/2, no equal to. That is my fault, and I apologize sincerely. My fault. So let's do this again. In order to round a mixed number, simply compare the fraction portion of a mixed number with 1/2. If the fraction of the given mixed number is greater than or equal to 1/2, increase the whole number part of the mixed number by 1 and drop the fraction portion. If the fraction of the given mixed number is less than or is just less than, okay, less than 1/2, leave the whole number part of the mixed number the same and still drop the fraction portion. Another way to round mixed numbers is to simply see if the numerator of the fraction portion is greater than or equal to, oh man, I really messed up here. I'm so sorry. There's no excuses. Or less than. Let me get rid of that. And let me get rid of this. And let me get rid of this. Again, that is my fault. That is my bad. And there's no excuse. I apologize. So, another way to round mixed numbers is to simply see if the numerator of the fraction portion is greater than or equal to or less than the 1/2 of the denominator portion. Okay, just less than, not less than or equal to. Okay, if the numerator is greater than or equal to, really sorry about all this, guys, sorry. If it's greater than or equal to 1/2, round the whole number up by 1 and drop the fraction. If the numerator is less than 1/2 of the denominator, leave the whole number part of the mixed number the same and drop the fraction. So let's go over this. 1/3, okay? I personally like just comparing it to 1/2 until you really understand how to understand if the fraction is less than 1/2. Because here, 1/3, okay, that's 1 out of 3 pieces. Sometimes people can't visualize that that is less than 1/2. So all you got to do is the following. Compare it to 1/2. My cross product is 2 there, 1 times 2. 3 times 1 is 3. So is 1/3 less than 1/2 or greater than 1/2? Huh? Really? 2 is greater than 3? So it's less than. So what happens? You drop the 1/3 and it becomes 4. 1 3/5. Compare it to 1/2. Cross products. 2 times 3 is 6. 5 times 1 is 5. Is 3/5 greater than 1/2 or less than 1/2? Guys? It's greater because 6 is greater than 5. So since it's greater, the 1 goes up to 2 and you drop the 3/5. 23 7/9. Compare it to 1/2. 2 times 7 is 14. 9 times 1 is 9. Who's the larger cross product, 14 or 9? So is 7/9 greater than 1/2 or less than 1/2? It's greater. So since it's greater, the whole number goes up by 1 and you drop the fraction. Last but not least, 9/10. Compare that to 1/2. 2 times 9 is 18. 10 times 1 is 10. Who's larger in cross products, 18 or 10? So, what fraction is greater, 9/10 or 1/2? 9/10 is greater than 1/2, so that means the 13 goes up by 1 to 14, and the fraction drops. Does that make sense, my brothers? You promise? All right, guys. So then now, we're going to practice. We have a comparing fractions visually. Okay? I just want to keep this here so that if you go home and watch the video, you can snap a picture of that. Hold on, don't take pictures yet. You have a comparing fractions numerically. You have a rounding mixed numbers. And that's it. Alrighty? So thank you so very much. I hope you learned a lot and have a wonderful and blessed day. Take care, gentlemen. And ladies out there in the cyber world. Good day.